Hi, welcome to my talk, Prototyping Spatial User Experiences, and thanks UX Day for having me. I'm Gregor Finger, a creative technologist at IXDS, and usually if we talk about this project, we are in a team, but Isabel Fringer, and it's no joke with the name, can't be here today, unfortunately. So, what's IXDS? IXDS is an innovation studio based in Munich and Berlin, and it's pretty much rooted in the field of human-computer interaction with an academic background. And we're pretty proud of our 4 days week. That's important. So, in general, it doesn't really matter what we do or on what kind of projects we work. We always work user-centered with a high amount of prototyping involved. And currently, we are roughly 85 people, rapidly growing, and our core skills around like technology, design, and business development usually gets us to the point where we work on integrated service solutions. So roughly 2 years ago, we created this venture model to strengthen our fields in certain industries. Where this project is located in is, for example, the Seamless Mobility Venture. Seamless Mobility Venture has the opportunity to work with some of the biggest clients or some of the biggest companies in Germany and Europe, and it's all around like automotive industry, public transportation sector, mobility service providers, and purely data-driven organizations, which translates directly to our main motivation, which is basically that we think that the future of mobility lies somewhere in the intersection of these areas. So, at the beginning of this year, the Hamburger Hochbahn approached us with a quite big challenge. They're building a new subway line, the U5, which will have around 25 new stops. And the planning started years ago, and the first stop's going to open in around 10 years. So it's a quite long scope. And think about what happened in the last 10 years of transportation. We got Mitfahrgelegenheiten.de, which is already gone again. And like on-demand car sharing, like Drive Now or Car2Go, bike rentals. We got segways, mono wheels, and these weird hoverboards kids in Berlin driving around with. Like, it's called hoverboard, but it has 2 wheels. And think about what's going to come in the next years, like autonomous taxis or, for example, Hyperloop concepts. Like, I went to a Hyperloop conference last month, and they were thinking about if it's possible to open the first tracks in between the next 10 to 15 years. So it's like they're really onto something. So the question was basically, what do customers expect from future train stations in times of digitization? And in 10 years, it's quite far away. Or, for example, how will the infrastructure be influenced from the future transportation modes, like also the architecture? So we started off with a quite common approach. We mapped out a customer journey with all important touch points. We even integrated when somebody starts thinking about a journey until they are back home. And we put all of these touch points into relation with certain trends, like just, for example, demographic, technology trends, or social trends. And in the second step, we sketched out a user-centered service vision in co-creation with the client. And in the end, we came up, or we figured out that everything is basically around how do you shift the idea from a traditional stop to a mobility hub where a journey is really flexible and doesn't really matter what kind of transportation mode you choose. So looking at present-day stations, I'm not sure if you know it, but it's Hamburg. Customers are confronted with overwhelming amount of information carriers, and it basically creates this patchwork look and feel of this kind of area. And obviously, it makes it really hard to navigate. And the architecture in this example is also not really helpful and barely supports your wayfinding. On the bigger picture, you can not even see that it's Hamburg from this perspective, or the city is not even barely reflected in the architecture or somehow. So we created the 14 principles, what a new mobility hub, we call it, should incorporate, with the 4 of them relevant for my talk now. So the first is basically being every mobility hub, every station, is supposed to be a small platform where different service providers meet and really interact and intersect on one on one point. But obviously, the service identity of the Hochbahn should not fade away. Instead, they need to incorporate every certain district of the city where they're in to just blend in with normal surroundings and really be a place for people and not just a pure reduction to functionality and like vandalism-proof interior design. But most important, obviously, if you integrate a lot of things, is that it's as easy to use as possible. And in terms of the U5, that's a big issue because everything will be fully automated, like the trains and the station or the hub. And the trains will operate in something called Gleiswechselbetrieb, which is basically the trains will determine, or the trains will decide where they stop on which side of the platform according to the circumstances. Like, for example, the doors can't open because of something, then trains will communicate and just decide, okay, I'm gonna take the other platform for now. And this all needs to be reflected. So the goal was basically how can we create a guiding system which is always up to date, dynamic and coherent over all touch points, physical and digital. So we went in an ideation phase and we came up with different ideas. We focused on the public screen doors or platform doors because autonomous trains usually have these doors. To just make sure that nobody runs in front of the train and everything is completely planned anyway. So we came up with different ideas how to signal processes, like when, or how to say, exactly. Will the train stop at this store, for example, or not? Because if the train is shorter, probably you are at the end of the platform where it doesn't stop. Or in what stage of the boarding process are we? Like, will the train start, will the doors start close in a second? Then I don't need to run, and all these kinds of things. Or where do I need to position around the door? Because a lot of people want to go out, and you need to wait, and all these kind of things. So we came up with different solutions for every single detail, and in the end we had this thing, okay, actually it's ABC testing what we want to do. But if you rely on like visual signals, timing, sound and these kind of things, it's quite hard to just put everything into a usual paper ABC testing. So we thought, okay, what do we usually do? We usually in these, usually at this point, we build a low fidelity prototype of a certain aspect. In this case, we rebuilt also for Hamburger Hochbahn, but some years ago, we rebuilt a third of a compartment of a train, focusing on one specific detail to test. But now that we talk of a whole station with a lot of different service providers interact with each other and not about the details anymore, we thought, okay, actually we need something bigger, and we decided for VR to go with. So how do you actually conduct a user test in VR? And that's basically the question, how do you not get distracted from wearing this bulky headset, which is tied to the ceiling, and therefore create high quality information? And in order to understand that, you need to understand how the brain works a little bit. So there's a famous experiment, the rubber hand illusion, which demonstrates quite well how you can trick the brain into accepting an artificial surrounding. And the experiment works like that. On the left side is the basic setup. The subject comes into the room and he gets an artificial hand attached. The artificial hand gets covered, like the connection gets covered by a blanket. And on the right side, you see a little bit here that is also a wall between the real and the artificial hand, so you can't see his real hand. In the second step, like both the artificial and the real hand get touched by a brush simultaneously from the facilitator. And as long as the subject basically believes that it must be his real hand, or the better way to say is like he doesn't verify anymore if it's his real hand or not, because he can see it, he gets the right signals, everything's fine. And in some versions of this experiment, it ends with the facilitator hits the artificial hand with a hammer, which obviously makes the subject a little bit like upset, because he gets these signals from the brain, like now you feel pain, it hurts for just a few milliseconds, and then it's gone again. But the emotions in that moment are true, so that's quite strong. So there are 3 phases. The first is this introduction phase where everything gets set up. The subject knows exactly what's going to happen. He's completely aware that there's like a artificial hand, that it gets covered and everything, that there's a brush, and the facilitator will like touch his hand simultaneously. He doesn't know that there's a hammer in the experiment before. And in the second phase, it's this orientation phase, we called it, where the facilitator brushes. As long as it's like a smooth transition into the experience phase, where he doesn't verify anymore and is able to feel this true pain. And it works the same with virtual reality. The effect is called the rubber hand illusion, the body transfer illusion. And it's sometimes used to treat things like phantom pain, for example. Or in this case, the fear of spiders. And it works exactly the same. Somebody comes in the room, sits down on a table, like really straight, because this person sits really straight, and gets a piece of paper on the table between the thumbs, so you can feel the difference on the table, like on the paper. And after a while, this like glass with spiders appear. And that's not really scary, but even if you don't fear of spiders, this makes you a little bit freak out if they walk around on the table. And I tested it some years ago with some colleagues, and they could even feel, like, imagine to feel the spiders tickle them on the thumb, and they were really like, whoa, what's up? Like, this is not real, but I can feel it. This is not cool. And really, the real fun part is if you then take a toothpick or something and like really scratch them on the thumb, then it's like, then they are completely gone. Yeah, so some people had nightmares of that. So, but back to our case, how do we get from this ABC testing on paper to a virtual reality prototype? We got the 3D assets from the architects, so all basic information, and we worked in a team of 3, one interaction designer, like producing all the signages, the videos, the animations, everything physical, one industrial designer polishing the 3D data, because if you work with architects, sometimes they have like one wall 10,000 times, and that's like a little bit bad for everything, for every work environment. And myself as creative technologist, putting everything together and building this like interactive scene where I integrated all the animations, moving train, opening doors, like basically everything you need to believe that it's somehow an what does it say? Believable surrounding. And the user test itself was made up exactly the same like we saw in the two examples. Like we had an introduction phase where every subject had 15 minutes to just come in, wear the headset, and walk through the scene. So basically, we had like a 4 by 5 meter room where they could walk around, and then they needed to teleport. And that was what we wanted to show them before. And to not like interfere with the user test, we did it on some parts of the station, like just dedicated for training, which were not part of the actual user test. And in the second phase, we took them out again, went to a classical ABC testing on paper for the parts which were possible. And that was important to just get to know them to just like make them familiar with the storyline. Because what's really important is that you get into this mindset like, I'm in a new city, I don't know where to go, my phone died, so how do I navigate? So we just prepared their mindset for it. And in the third phase, we went back to the platform in virtual reality and asked them quite broad questions, like, can you just go and take the next train? Or can you go and find a door with 3 spots? Or can you tell us where the next, when the next 3 trains are coming or leaving? And like that was like the one thing, and we got like a lot of qualitative data. But in the back, we were able to just record everything, all movements, everywhere they were going, and also and see where they were looking at, and put the recordings on top of each other, so we could really compare also in a quantitative way, how the design is doing. Because here, for example, you can already see that this space over here will be something with a little like where there will be some problems at one point, because both of these 2 people walk exactly on the same spot, even if they were not in the same time in this virtual reality. So our key learnings using virtual reality is basically the best thing is you ask questions and you get like not just like abstract articulation of someone from somebody who like thinks what he would have been doing in this kind of situation, but you get like the real interactions and movements and behaviors, because you can just look at it and ask completely different questions. You also get a lot of off-track information. For example, we left an arrow accidentally, which indicated the direction of the train. And people reported that it was really, really helpful that they knew from before, because then they could like somehow integrate it in their spatial knowledge, that they know like, okay, if the train goes from there, then I can, then I go usually like probably I'm gonna go up northwards or these kind of things, and they could do this before this like moment of, okay, the train is coming, I need to go. So it was somehow quite good for them. And simulating in that big scale is a big opportunity for complex systems. So we could also integrate much more interactions. Now we focused on the platform, but of course we could also focus on everything else, the Verteilerebene, for example. But doing all of this is also like a problem, because infinite possibilities also means like basically being paralyzed of like possibilities to do. So it's really hard to focus on the details, basically. So what are the visions? Where do we go from here? We see a big potential in growing a continuously test environment along the project. Because if something changes, like the architecture or train timings or signage systems, we can just drop in new assets and test right away. So now we have a really, really quick way to just do some really complex things. Or we could extend the field of research, for example, testing for disabilities, like colorblind people. How do they experience, how do they find their way? Because for now, this is basically a blind spot for us, or like somehow. Or integrate stress tests, like how does it feel to be on this really small platform with 100 people walking around you, finding their way? Is there enough space and these kind of things? I mean, sure, you can calculate these things, but usually you just see it when it's there. Or integrate smoke and fire emergencies, like can you find the exit? Do you remember where it is? Do you know? Can you see the signs? And I want to end my talk with a quote from Sasha, immersive visual producer of NASA. Bring 3D designs into the world and solve problems before they're real. Thanks.